Okay, let's go over this homework. I know the argon is providing 3 atmospheres of the 9, so how much is the helium providing?
6.
6. Great. Okay, so what does that tell us about the, they removed all those things. What's that tell us about the two gases?
There's twice as much.
There's literally 2 times helium atoms. You okay with that? That's why it has twice as much pressure. Okay, so if in a container I've got 40 grams of argon, and that equals 3 atmospheres, well, what does 40 grams of argon equal? Approximately. Because I said about with this one. It's about a mole. The molar mass for argon is like 39.9 something or other. So this is about 1 mole of argon. So if 1 mole of argon equals 3 atmospheres, then how much is 6 atmospheres equal to in moles?
Of argon?
No, doesn't matter. It could be anything, 2, right? In this container, 1 mole equals 3 atmospheres, just based off of the temperature and the size of the container. And so if I've got the same container, but something is providing 6 atmospheres, there must be twice as many of them. So then this is going to be 2 moles. Okay, so what's the answer? Or sorry, I must have 2 moles of helium. Are we okay with that? Are we following this logic so far? What's that eyebrow for? That is a no. Okay, so are you with me with that first step there, that 40 grams is 3 atmospheres? The last question had, this container has 3 atmospheres of argon in it. And then the next question says, in that container there's 40 grams of argon. So 40 grams of argon is responsible for 3 atmospheres of pressure. So 40 grams of argon just happens to be equal to about a mole of argon. So that means there must be 1 mole of argon atoms bouncing around inside that container, and they provide 3 atmospheres of pressure. Okay, so I also have some other gas, in this case helium, providing 6 atmospheres of pressure. So since those 2 gases are at the same temperature and at the inside the same size container, how many more heliums are there than argons? 2 times, right? And so if we just figured out that there's 1 mole of argon in there, how many moles of helium must be in there? 2. Okay. So if you have 2 moles of helium, what's the mass of helium that I'm looking at? About 8 grams. Did you say 80? How about 1 mole is 4, and 2 moles is 8? You with that? So this is 2 moles of helium, and so two moles of helium is equal to about 8 grams of helium.
So doing the pressure volume thing would be wrong because that's a change in pressure and not like
There's no changes here.
yeah.
Yeah. This is all just like a thought exercise. If I have this much of this and it's doing this, and I have this much of that, what must it be doing, kind of stuff.
So the answer to the first one is 6 and
The answer to the second one is 8 grams.
but not because it's 9 minus 3 is 6.
No, 9 minus,
The total pressure in the canister is 9.
oh, this one up here?
Yeah.
Yeah. This one up here is 6 because 9 minus 3 is 6, but not the next one. Yeah. Are we satisfied with that one? Talk about that one anymore? No? All right, so what do we got here? 25 grams of tin reacts with zinc. What are the products? How much, what's left over? How much you got? Okay, one of those. Alright, so is this smaller? That's a little bit smaller. What's the actual reaction?
Why is the zinc fluoride?
If you put solid, I wouldn't be terribly upset, but it is. I know it's not on our list.
But why?
Because the chlorides, bromides, and iodides are almost always soluble, and so is the fluoride. It's just not as often. So if you've got a fluoride, it's probably soluble. We okay with that balanced equation? Okay, so I'm going to start off with 25 grams of SNF4, 1 mole SNF4, grams SNF4. So I've got 118.71 plus 18.999 times 4. So 194.702. And then for every 1 mole of SNF4, I'll do one mole of tin, and then 1 mole of tin is 118.71 grams of tin. So 25 divided by the 194 times 118.71. And so I got 15, I'll just write 15, that's fine. 15 grams of tin made. Alright, so then I'll do 25 grams of zinc, 1 mole of zinc, and it's 65.39 grams of zinc. Every 2 moles of zinc, I need 1 mole, or I'll make 1 mole of tin. For every 1 mole of tin, it's 118.71 grams of tin. Grams of tin. Okay. So 25 divided by 65.39 divided by 2 times 118.71. So I got 23. Okay. So what do we know? Tin fluoride is my limiting reagent. So in this particular problem, when this is over, I'm gonna have 0 grams of tin fluoride. I'll have some leftover zinc. I'll have 15 grams of tin in the container. So what I need to know is how much of that zinc fluoride is gonna be made. So I'll go with back to my 25 grams of tin fluoride, 1 mole tin fluoride, 194.702 grams tin fluoride, 1 mole tin fluoride, 2 moles of zinc fluoride. 1 mole of zinc fluoride. Grams of zinc fluoride. All right, so 65.39 plus 18.998 times 2. So this is 103.386 times 2 times 25 divided by 194.702. I get 26 and a half. Okay. So what I know is I've got 0 grams of tin fluoride in the container. I've got 15 grams of tin in the container. I have 26 and a half grams of zinc fluoride in the container. And then my leftover zinc in the container. So if I started off with 50 grams of stuff, and now I ended up with, what is that? 15 and 26 and a half, 0.5. Why would I use 27? I'm not at the last calculation yet, though. We can round later if we want. 41 and a half. So what is this 41 and a half? So these are the products that I made. So I made 41 and a half grams of stuff, but I started with 50 grams of stuff. So of my starting material, how much stuff is left? So I have 8.5 grams. So I've got 8.5 grams of zinc that's left over. And if we want to make Sam happy now that we're finished with this, we can say that I've got, since this equation here doesn't matter, I'll just erase this. And we will go with 0 grams of tin 4-fluoride. We will have 9 leftover grams of zinc. We will have 26 grams of zinc fluoride created, and I'll have 15 grams of tin created. That good? Write out the reaction. Okay, so I've got, what's the formula for lithium iodide? LiI. And PbNO3 2. And I get LiNO3, and I get PbI2, we need a 2 right there, and I'm going to need a 2 right there. Okay, so there's my molecular equation. What's my full ionic equation look like? What's your procedure for that? Everything?
The aqueous stuff and other constituents like the water.
Yeah, so that aqueous means they're already broken apart, so I'll go ahead and break them apart. So what has changed? The lead was aqueous on this side. The iodide was aqueous on this side. And on this side, they're a solid. Okay. Highest to lowest vapor pressure on this one? So what am I looking for vapor pressure? Which one of these things has the strongest intermolecular forces? So the ionic compound. So the highest vapor pressure to the lowest vapor pressure. So where's Epsom salt going to be? On the bottom of the list. It's got the strongest intermolecular forces, so it's going to have the lowest vapor pressure. It is the least likely to just turn into a gas. So who's got the highest vapor pressure? The hydrogen gas, for sure. Why does the hydrogen gas have the highest vapor pressure? That's not a good reason. Propane's a gas as well. So are they tied? Nope.
Oh, because it's got that,
It's nonpolar.
the first one on the list.
Yeah. It's the first one on the list. The dispersion force.
Yes.
So we'll say that the propane is number 2 on this list for vapor pressure, second highest. Propane also is nonpolar. Propane also only deals with dispersion forces. So why does hydrogen have a higher vapor pressure than the propane? It's smaller. So how many electrons can I disperse with my dispersion forces on a hydrogen gas? 2. It's hydrogen gas, right? So 2 atoms, 2 electrons. So I can only disperse 2 electrons to the other side of the molecule when the hydrogens get close to each other. So they're not going to be able to form a very large partial positive and partial negative. That same is true for the propane, but the propane is significantly larger. It's got 3 carbons in it, each with 6 electrons, and it's got another 8 hydrogens, each with another electron. So since it's a larger molecule, I can skew its electrons more easily. We good with that? Okay, so who is 3 and who is 4? All right, so I'll put gold here. So why is ethanol in the middle? Say again?
Polar molecule.
Special polar molecule. Whoa. Don't do that. Or that. Stop it. Right? In that ethanol molecule, there's an oxygen bonded to a hydrogen. So that constitutes a hydrogen bond because this is a pretty large negative and this is a pretty large positive as far as partials go, as big as they get as far as partials go. So hydrogen bond for number 3, these 2 guys are both dispersion. And the hydrogen is smaller, so it's at the top of the list. And then obviously gold has the sea of electrons metal interaction. So that's very strong, but then the ionics are the strongest. So the Epsom salt is least likely to just vaporize into a gas. Not that it won't, it does, it's just least likely, smallest amount.